We're here with Shane McClellan from Ericsson, and today we're talking about 5G. Hi Shane, welcome.
Thank you very much. Glad to be here at the big 5G event.
Exciting stuff going on.
It
is. 5G transport, it's the area that I look at, area that you're very much involved
passionate about it.
I'm sure you're talking to a lot of operators these days. As you do the rounds, what are you hearing from your customers and potential customers about the biggest challenges to the transport network?
Sure. So we hear over and over again that 5G is a game changer. And as I dig more and more into it, being a transport person, learning more about the RAN and the mobile edge compute environment, it truly is a game changer. And our customers' to-do list, when I look at their whiteboards of things to do, is super long. So the way that I can kind of put it together in my head is kind of create three dimensions of the challenges that they face. And the first one's operational, the second one's technical, and the third one's commercial. Right, so if we take the operational dimension and look into that from a challenges perspective, as you go up spectrum, right, the site, the radio site coverage area shrinks, you got to deploy more radios, someone's got to connect them. So where, as an operator, where am I going to get the real estate, the power, and the connectivity to be able to connect all these radios, right? So we're looking at maybe doubling the number of radio sites in North America over the next 5 years. It took 25 years for us as an industry to get 350,000-ish cell sites up and running. How are we going to double that in the next 5 years without changing the operational game? In terms of competence, in terms of equipment, in terms of machine learning, automation, those types of things. And that all has impact on the transport network and how that comes to bear. The second one is the technical items, and we talked just a bit about the going up spectrum and the densification pieces, but in addition to the connectivity, we also have the capacity implications and the latency implications. So when we change those RAN architectures, and we add centralized RAN and virtualized RAN and elastic RAN to the traditional distributed RAN, the architecture changes, the amount of capacity changes on those interfaces, the latency requirements on those interfaces are all different, and that all has a direct impact on how you design and architect the transport network. And then last is the commercial dimension, and that's the big one. What use case is going to justify my investment in all this new equipment? So the use case in terms of transport is vitally important in terms of where am I going to put the workload, how am I going to serve that user with what connectivity? So the underlying connectivity between all these distributed radio elements is a major, major concern for the customers, and that's what we at Ericsson are trying to work with them today on.
It sure is. So you mentioned centralizing the RAN. Centralized RAN creates a new segment of the network, the front haul. We're hearing a lot of different things about front haul. Yeah. What's Ericsson's position? What are you recommending to your customers?
It's an increasingly hot topic, right? Increasingly hot topic. When I learn more and more about our radio portfolio and I look at 5G NR and the number of CPRI 8s coming out of 5G NR, and I look at the new 5G NRs on the roadmap coming out with eCPRI connections, right? We've got just the sheer number of fiber that's going to have to be deployed in the front haul environment, plus new protocols coming in that we're not used to yet. So it creates an entirely new challenge and opportunity for the customers and for Ericsson. So due to the variability of the RAN architectures, right? We have in the old days we got DRAN, and front haul was simply dark fiber connecting the radio at the tower down to the baseband in the HUD at the bottom of the tower. Straightforward, simple, homogeneous, no issues, right? But as that RAN site disaggregates, and those remote radio heads go everywhere, and centralized RAN hubs start to be positioned potentially for mobile edge compute locations in the future, what we find is that variability requires some front haul options, right? So we have to have medium options in terms of fiber options and microwave options, right? Because you might not be able to get fiber everywhere. So at Ericsson, we have this portfolio of front haul products where we can position dark fiber, right? BiDi SFP type solutions to address fiber exhaust issues, passive DWDM, active DWDM, and a microwave option. So we have native eCPRI transport over microwave link for our customers that just can't get fiber everywhere. So that portfolio, that breadth of options is important as we move into this 5G world.
I'm interested just to pick up on microwave. You actually mentioned it a couple times. I'm a fiber guy. Originally, everybody thought it was going to be all fiber for 5G, but Ericsson does talk quite a bit about microwave. In the U.S. and I guess North America, what realistically, what is the role of microwave?
Yeah, we're blessed in North America. As I talk to my peers in the other parts of the world, we're blessed in North America because we are a fiber-rich environment, right? So heard earlier today, someone mentioned the bits want to go to fiber as fast as they can. right? It's just kind of a natural thing. But short answer to the question, microwave does have a space in 5G transport moving forward. And frankly, just the reason is that you just can't get fiber everywhere you need it as fast as you'd like it to keep your radio deployments on track. And sometimes it's just inconvenient to deploy, right? And so we want to look at some alternatives for fiber, and so microwave has a place in there. And traditionally microwave kind of caps out at about 400, 500 megs over the link. But in 5G we know we have to go to 10 gig, 25 gig, etc., right? So advances in microwave technology like higher order QAM, adaptive modulation, MIMO, radio link bonding, all these technologies have come to bear now and are being available on the market today to bring microwave into the gigabit realm. So we're deployed microwave radios for our customers today that are operating at 5 gig, 10 gig. We've done trials with our customers globally at 20 gig, 40 gig, right? Our Ericsson research is working on the D and W bands in microwave, bringing us into over 100 gig, right? So microwave has a long future, right? It's going to have its place because we can't get fiber everywhere as fast as we like it, as cheap as we like it. And so it will be part of the 5G ecosystem in the future.
Tools in the toolbox is the term.
Absolutely.
This last question for you on Ericsson also has routing products on your own, and then also I think through partnerships.
Partnership with Juniper, right?
How do you see the routing evolve as we move from 4G to requirements of 5G?
Yeah, there's two areas I think that are going to evolve in the routing space, and it has to kind of do with where the routing's at in the network. So, in 4G, we had a very homogeneous kind of routing environment in the network. So we had a cell site router, and you can argue. I've had customers ask me and challenge me, did we even need a cell site router there, right? Because really, what was it? Was it actually routing? It's more like a static IP route coming off of one port, maybe a dual port for resiliency, to an ag point, and at the ag point, the routing would start to happen, right? And so in 5G, I view the router as more of a platform to enable 5G rather than just the cell site router. And so what I mean by that is there are basics that will change, so router basics that will change. So we'll have to have higher capacity ports and more density at the access than we've ever had before. So 10 gig, 25 gig, 100 gig interfaces at the access network. We're going to have higher port densities because more radios are going to be connected, more basebands are going to be connected, and in addition, the form factors are going to have to vary because the deployment models, you might want to have a pole-mounted cell site router or a cabinet-based cell site router. It's not just going to be an environmentally controlled HUD. So those form factors are going to change as well. In addition to that, there are new functionalities that are going to run on the router platform because they just don't make sense to run anywhere else, right? You don't want to put them on a baseband because you don't want to burden the baseband with more things. Baseband will virtualize eventually, so things like timing and sync distribution over the network, very important for 5G in terms of TDD radios. So having an onboard timing and sync source that can support GPS failures or back up the GPS is a new functionality that's going to come on that platform. We're going to have distributed IPsec gateway to enable automation and rapid deployment of cell sites. So, being able to set up an IPsec tunnel from a baseband to a set gateway to a packet core, you're going to have to do it real fast, and it's going to have to be automated, right? So having remote distributed IPsec functionality at the site is going to be better than having to set up lots of IPsec tunnels across the core of the network. The other one are deep buffers. So our mobile content we know is inherently bursty. But our mobile content's also layered and rich, right? We download a lot of embedded videos in our news feeds, and every one of those embedded videos come from a different place in the network, and everybody knows you wait for the blue line to fill up on your phone before all the videos are available. Well, that's because you're getting TPC retransmits in the network waiting for that video to show up. The deep buffers at the access or at the edge, the far edge, is going to smooth that video traffic to the end device, allowing for a better QoE. So those kind of new functionalities will all become available on that, what we call a cell site router today.
Interesting, so functions and capacity is a combination. I think there's no question that 5G's really re-energized the telecom industry.
No doubt. Yeah, it's made us old bit movers cool again.
It is. I look forward to tracking your progress over the next couple of years.
Absolutely.
All right, thank you. All right.
Appreciate it.